Alright, today we're moving from uh, one-step equations to multi-step equations. You do not have to take down this first example, but the ones after this you'll probably want. But this helps introduce what a multi-step equation looks like. Alright, so you're taking a cab to the grocery store. There's a flat fee of $2 upon entrance of the cab. From there you are charged 50 cents per mile. If your total fare is $20, how many miles did you drive? Alright, so we can set this up. So we know that our equation equals $20 total, and that we are charged $2 upon entering the vehicle. I'm just going to write that as 2, and we are charged 50 cents per mile. So 0.5n or m or 0.5m, and we can go ahead and solve for m. And what we're going to do to solve for m is the same thing we did for one-step equations, except for we're going to follow a couple different steps here. So remember, whatever we do to one side of the equation, we're going to do to the other. The first thing I like to do is look at and find my variable term, okay, the term that has the variable with it, and I'm going to ask myself what's happening to that. All right, well, we're adding 2, so I'm going to do the opposite of that. And I'm left with 0.5 or 0.5m equals 18. All right, and now I can look at it even further here. We've got the variable term by itself, but now we want to get rid of this coefficient. We're multiplying by 0.5, so we can divide by 0.5 on both sides. And we can get our answer. 0.5 divided by 0.5 cancels. So m equals, and how many halves go into 18? Well, that's pretty much double 18. So 36, oops, that's not dollars, we solve for miles. So 36 miles with that fare, right? So that's an example to introduce us. But here are some just generic examples, and they each have their own little trick to them. So this one, solve for 10 equals 6 minus 2x. Alright, again, draw my line. Whatever I do to one side, I'm going to do to the other. I'm going to find my variable term. And I'm going to include that negative with it, minus sign, so we're going to consider that a negative 2x. What's happening to it? Well, 6 is positive, so I'm going to consider that adding 6. So negative 2x plus 6. So what I'm going to do to get rid of 6 is subtract it. I'm going to do that on both sides. So now this drops down. Alright. And now, this is why the signs in front of the terms are so important. We're not going to divide, so we have negative 2 times x. We're not going to divide by positive 2. I'm going to divide by negative 2. And it's going to completely change what we get for an answer. So negative 2 divided by negative 2 cancels. 4 divided by negative 2 is negative 2. And if you're looking, make sure you get that example down. If you're looking to check and see if you got it right, take your negative 2, plug it back in for x. Or 10 equals 6 minus 2, negative 2, which is negative 4, and 6 plus 4 is 10. So that's one way you can check. All right, this one is a bit more involved. All right, so we have q over 15 minus 1/5 equals 3/5. A couple different options here. Many of you will think, well, I should probably get a common denominator, and that can definitely do the trick. Or you can notice, once you find your variable term, that if I add 1/5 to both sides, so the opposite of subtracting 1/5, the two fractions on the right side already have the same denominator. So 3/5 plus 1/5 is 4/5. Now we have q divided by 15 equals 4/5. So since we're dividing by 15, we're going to multiply They're inverses, but you can always multiply by reciprocals too. That doesn't necessarily apply to this one as far as what we were looking at yesterday, but same concept anyway. So we're left with q over 1, or just q. And then we can do a little shortcut over here. Divide both of these by 5. And we have 4 times 3, or just q equals 12. And you can go through and check that and make sure that it works out. If I put 12 in for q, that's 12/15ths, and I can divide this by 3, reduce it, and then we get 4/5 minus 1/5, and that does happen to equal 3/5, so we have the correct answer there. Alright, one other option for this, and this is something that many of you will use instead. Make sure you have that example down, but you might prefer this method. Remember, we can do whatever we want to both sides of the equation as long as we do it to both sides of the equation. So what I'm going to do is multiply through by 15. I'm going to take the least common multiple, basically, of the denominators. So I'm looking at these denominators. The least common multiple is 15. All right, so if I multiply through by 15, we get rid of our fractions completely. Now, here's the trick though. If I multiply the left side by 15, that means I got to multiply both of these terms by 15. So it ends up looking like this. And then we can see what we get. So here's the reason I'm doing it. 15 and 15 will cancel, and we're left with just q. And then 15 and 5, we can divide both of these by 5. I have 1 times 3, which is 3, and 1 times 1 is 3 over 1, or just 3. And if I take 15 times, or on the right side then, again, I can divide both of these by 5. 3 times 3 is 9 over 1. 9 over 1 is just 9. And then we have a nice equation, one-step equation to solve, where I look at my variable, we're subtracting 3. So I add 3 to both sides, and we still get q equals 12. I like multiplying through by the least common multiple because it gets rid of your fractions. And we'll work with that tomorrow as well. Okay, real quick, 2 last ones here. These are a little different because you have to do some simplification before you do anything. For instance, I can combine these 2 terms. So we have negative 8a plus 2a. So you can do this one of 2 ways. You could write 3 plus negative 6a, or negative 6a plus 3. Or 3 minus 6a equals 8. And now we go about this just like we did before. So I'm going to subtract 3 on both sides, keeping everything balanced. I'm left with negative 6a equals 5. Looks like we're going to get a decimal here, and that's okay. The last step will be we're multiplying a by negative 6, so we'll do the opposite of that, which is divide, and a equals negative 5/6. It does not matter where that negative goes. You could put negative 5 over 6, or 5 over negative 6, or you can just put the negative out front like I did. Alright, and you can check that real quick too. You might want to you can go back to the beginning, or if you want to look at what you combined, that might make it easier too. So for instance, if I put back in negative 5/6 for a, our negatives cancel out. Negative times a negative is a positive. 6's cancel out. So you're left with 5 over 1, or 5, plus 3, which equals 8. So it looks like we got the right answer. So you can always go back and check. All right. Lastly, we want to distribute first. So remember, you can do it this one of two ways. You can do 4 times x and get 4x. And you can do 4 times negative 2. So you can either say plus negative 8 or minus 8. We also have plus 2x. And then that equals 40. So distribution first. And then we want to look for any terms we can combine. So positive 4x plus 2x is 6x. We still have a minus 8 equals 40. And now we go about this just like we did before. So what's happening to 6x? We're subtracting 8. So I'll add 8 to both sides. Negative 8 plus 8 cancels. So 6x equals 48. And to show that x is 8, we know 6 times 8 is 48. But to show it, we would do the opposite of multiplication. There we go. And again, you can go back and check that real quick. Alright, so 8 minus 2 is 6, and 4 times 6 is 24, and 2 times 8 is 16. Well, 24 plus 16 equals 40, so we got the right answer. Alright, so lots of different situations we can run into, and I will show you some more tricks that you can use tomorrow. The main one that you'll want to keep in mind will be like these fraction ones where you can multiply through by a least common multiple to get rid of your fractions. All right.